We'll continue 3.5 in this lesson, and we'll specifically be looking at the graphs of rational functions. Okay, so this is going to be the strategy, and there's going to be 2 slides here for the steps. So I would print this off, go back to the steps. So on the first step, you're going to determine whether the graph of f has symmetry. And we have talked about this in the past. To have y-axis symmetry, f of negative x equals f of x. To have origin symmetry, f of negative x equals negative f of x. Step 2 is to find the y-intercept, if there is one, by solving for f of 0. Step 3 is to find the x-intercepts, if there are any, by solving to figure out what x's would make the equation equal 0. Step 4 is to find any vertical asymptotes by solving the equation. Find the horizontal asymptote, if there is one, using the rule for determining it that we learned in the last lesson. Plot at least one point between and beyond each x-intercept and vertical asymptote. And 7 is to use the information obtained previously to graph the function between and beyond. So we'll walk through this step by step. So we're trying to graph 3x minus 3 divided by x minus 2. So our first step is to determine symmetry. So we want to know, let's try this first. If we find f of negative x, is it equal to the original f of x? So if I replace all my x's with negative x, let's see what happens. Well, that becomes negative 3x minus 3 over negative x minus 2, which is not equal to the original. And it's also not equal to negative f of x, because that would have needed to show all the signs changing. So because this does not equal either of these, the graph has neither y-axis symmetry or origin, so it doesn't have any of those symmetries. Step 2 is to find the y-intercept. So to do that, we have to solve for f of 0, because when the x is 0, we'll be able to find our y-intercept. So we replace the x's with zeros here. 3 times 0 is 0, which is, and then minus 3. So you end up with 0 minus 3 is negative 3, over 0 minus 2 is negative 2, so that just becomes 3 over 2. So when the x is 0, the y is 3 over 2, which is 1.5. So that means it crosses right there. Now we'll find the x-intercept. So this is to figure out what are the zeros, or what are the x's that will make the equation equal 0. So 3x minus 3 equals 0. We can solve that one. We just set the top equal to 0. Now if you look back at your steps, to find these we can figure out when p of x equals 0, which just means find when the numerator equals 0. So we only need to worry about the numerator here. So 3x minus 3 equals 0, add the 3, you get 3x equals 3, divided by 3, you get x equals 1. So that means it's going to pass through at 1, 0. If I put that on my graph, I have a point here as an x-intercept. Step 4, find the vertical asymptote. So we did this in the previous video, where you have to figure out when is the bottom equal to 0. So x minus 2 equals 0, just add the 2 and you get x equals 2. That's the vertical one. And the horizontal one is where you had to look at the degrees. So these are both 1s. They have the same degree. So then you take these coefficients divided by each other. 3 divided by 1 equals 3. So y equals 3 is going to be our horizontal asymptote. Okay, so you can see that we drew those in. We found our x-intercept is 1, 0. That's one of the black dots. And then we have, so let me put it right here. Then the y-intercept was right here. And we said we had a vertical asymptote at x equals 2. So that's going to be a good starting point. And now you're going to plot points that are between and beyond the x-intercept and this vertical asymptote. So you can see that we chose a few places before it so we can find, okay, this would help us find a dot. We could find a dot somewhere in here, somewhere at when x is 3 divided by 2. So we're just picking different x's that we can try. So all these circled x's are ones we're going to plug into a table into our function and see what we get. So here's our original function. So I'll just show you where they got one of these. So they, to find x at -1, they did 3 times -1 minus 3 over -1 minus 2. You get -3 minus 3 over -3, which is -6 divided by -3, and you get 2. So that's where they got this. So that means we have a coordinate right here, -1, comma 2 is going to be a coordinate we can put on the graph. And then you would do the same process. They chose 5 points. You're just supposed to pick some points that are in front of the vertical asymptote and past it. Okay, so all those are the black points. We have our x-intercept, y-intercept, and then a few other points. Then we plotted the vertical asymptote, and the horizontal one is the green one. And then you can go ahead and finish your curve out knowing that it's going to be approaching those green and blue lines. And there are a few other ones in the book, so I just wrote down some examples that I won't take the time in the video. I'm going to just have you go back, and they walk them through step by step, and they have really good visuals to help you understand how to graph these some more. Okay, now we're going to look at a slanted line that the curves are going to approach. So it will have a slant asymptote if the degree of the numerator is 1 more than the degree of the denominator. Okay, so we can see that the degree of the numerator is 2 and the bottom is 1. Okay, also x minus 3 is not a factor of the top, so there is going to be a slant. So to find the equation of the slant, we're going to divide the numerator by the denominator. So we're going to divide by, remember when we do our synthetic division, it's always a minus something, so we're going to just put the 3 there, and then we have a 1, a -4, and a -5 in the numerator. And then we bring down the 1. That gives you 3. -4 plus 3 is -1. 3 times -1 is -3. So our remainder is -8. So this arrow can be shifted over. This is the remainder, which is -8. But remember when you write it, so let's look at our original. It was x squared. So that means this is going to be x. So we'd have 1x minus 1. Then we have -8 as our remainder, but you have to put what we divided by was the x minus 3. That goes on the bottom. So that's what we get when we do the division. Okay, so we just said that when we did this, we got 1x minus 1 minus 8 over x minus 3. If we drop the remainder, then we're going to have the slant asymptotes equation. So we're just going to ignore the remainder pretty much, which is just 1x minus 1, or you could just say x minus 1. And to graph that, that means this is the y-intercept, and our slope is whatever's in front of the x, which is just a 1. So you can see in the graph, we start at the y-intercept of -1. Then you have a slope up 1 over 1, up 1 over 1, and it keeps going. So that's where our slant is. And you could do the vertical one also, because the vertical comes from the denominator. So that 0 would have had to be a 3. So that's where they got the x equals 3. And you can see that our blue arrows approach both of those lines, both of the green dotted lines. Okay, let's try another one. So this one I have written out step by step. So we start with this degrees to make sure we're doing what we need to do. This is a 2, this is a 1. So it is exactly 1 more, the top is, than the bottom. So now to find the equation, we're going to do synthetic division. So they took this 2, -5, and 7 and put them down here. Then they did synthetic division. This is the remainder. So from this division, we end up getting 2x minus 1 plus 5 over what we were dividing by, which was x minus 2. Then we'll drop the remainder to get the slant. So we would have this. Okay, we'll finish with an application problem. So a company is planning to manufacture wheelchairs that are light, fast, and beautiful. The fixed monthly cost will be $500,000 and it will cost $400 to produce each radically innovative chair. Write the cost function. So the cost equals $500,000. That's the monthly cost that's fixed. Then $400 each. That's why we have an X here. Okay, write the average cost function of producing X wheelchairs. And to find that average cost, you would take your total cost divided by the number of wheelchairs. I'll just put number of chairs produced. And we said that X represented the wheelchairs. So our total cost goes on the top divided by the number of wheelchairs, X, on the bottom. Okay, now we're going to find and interpret if we had 1,000 for the cost. So the average cost of producing 1,000, we can just replace our X's with 1,000. And you get 900. So the average cost per wheelchair of producing 1,000 of them is $900. Okay, now let's see if we produce 10,000. So now you replace our X's with 10,000. The average cost per wheelchair of producing 10,000 of them is $450 per month. And then 100,000, again, just replace our X's with 100,000, you get 405. So the average cost per wheelchair of producing 100,000 wheelchairs per month is $405 per wheelchair. Okay, now we're going to find the horizontal asymptote for the average cost. So if you think back to how we found the horizontal asymptotes, if the degrees were the same, so they rearranged it here, These both have a degree of 1. So then you have to divide your coefficients. So we take 400 divided by 1 on the bottom. Just equals 400 for our horizontal. Okay, so the horizontal asymptote for this function is y equals 400. So describe what this represents. So the cost per wheelchair is going to be approaching the $400 as more wheelchairs are produced. So you would end up with a picture where that cost is approaching the $400 mark.